In this tutorial, I'm going to find the eigenvalues of the matrix A, and that is elements 1, 2, minus 2, 1. By definition, eigenvalues are roots of the characteristic polynomial. And the characteristic polynomial, which we denote by Pn of lambda, is the determinant of A minus lambda In. And the In there in the formula for the characteristic polynomial is the identity matrix. It will be the same size as the given matrix. In this case, our matrix there is a 2 by 2, so our In will also be a 2 by 2 matrix. So in this case, we would have our identity matrix there is 1, 0, 0, 1, which is a 2 by 2 matrix. That matrix there has ones on the diagonal, and in the formula for the characteristic polynomial, we are multiplying it by lambda. And this will result in having lambda on the diagonal there. And when you subtract that from the matrix A, it will result in subtracting lambda from elements which are on the diagonal of the matrix A. So our characteristic polynomial there will become the determinant of 1 minus lambda 2 minus 2, 1 minus lambda. What we are having there is the determinant of a 2 by 2 matrix. The determinant of the matrix A, B, C, D is equals to AD minus BC. So using that formula there, we have that determinant is 1 minus lambda multiplied by 1 minus lambda plus 4. We can simplify that to lambda squared minus 2 lambda plus 5. So what we are having there is the characteristic polynomial is lambda squared minus 2 lambda plus 5. Eigenvalues are roots of the characteristic polynomial. To get the roots of the polynomial Pn of lambda there, we have to set Pn of lambda equals to 0. When we do that, we have lambda squared minus 2 lambda plus 5 is equals to 0. So to find the roots of this polynomial now, what we can try to do is try to check if it has any factors. In this case, we are looking for two numbers, which when you multiply them, they give us a 5. When we add them, they give us a minus 2. We can't find such numbers, so we can try to use the quadratic formula. For the quadratic formula there, comparing with the equation which is on the left, we see that our A there is a 1. Our B is a minus 2. And our C, the constant there, is a 5. So if we substitute those values of A, B, and C into the quadratic formula there, we would have our lambda is equals to 2 plus or minus square root of 4 minus 20 divided by 2. 4 minus 20 is a minus 16, and the square root of minus 16 will give us a 4i. Because the square root of a negative number gives us an imaginary number. So we would have our lambda there is equals to 2 plus or minus 4i divided by 2. When we divide throughout by the 2 there, we'll get that our first eigenvalue is 1 plus 2i. The second eigenvalue is 1 minus 2i. So what we are having there for the matrix A there, it has complex eigenvalues. Lambda 1 is equals to 1 plus 2i, lambda 2 is equals to 1 minus 2i.